Welcome to today's deep dive.
Yeah.
We're going to be looking at clouds.
Okay.
You know, those fluffy things we see in the sky?
Right.
But we're going to be looking at them from a scientific point of view.
Interesting.
We'll be exploring 5 fascinating factoids
Okay.
from Cocktail Party Chemistry, episode 181, The Chemistry of Clouds, Water, Vapor Wonders.
Sounds like fun.
To really dig into what makes clouds so much more than meets the eye.
I'm excited.
It's amazing how something we see every day can be so complex when you start looking at the science behind it.
It really is.
You know what they say?
What's that?
The more you know,
Yeah.
the more you realize you don't know.
Haha, yeah.
So let's start with this first factoid.
Okay.
It's about how clouds aren't just those fluffy cotton balls we imagine.
Right.
They're actually intricate systems involving water vapor, aerosols, and ice crystals.
Now that's a great place to start.
Yeah,
It really sets the stage for understanding just how much chemistry is involved in cloud formation.
that's true,
It's not simply water evaporating and then magically reappearing as a cloud.
right?
You have these tiny particles called aerosols,
Uh-huh.
things like dust, pollen,
Okay,
even sea salt.
interesting.
They act as nuclei for water molecules to condense around.
So these aerosols are like little gathering points for the water vapor,
Exactly.
Sure, okay.
And depending on the temperature and pressure,
right?
that condensed water can remain as liquid droplets, forming the clouds we typically see,
Oh, interesting.
or it can freeze into ice crystals,
Okay.
leading to the formation of different types of clouds,
So different types of clouds.
like cirrus clouds,
Uh-huh.
those wispy, feathery ones you often see high in the sky.
Okay, so the type of cloud we see is actually determined by the conditions under which it formed and what kind of particles were present.
Precisely.
That makes sense.
And that's just scratching the surface.
Really?
The chemical composition of a cloud
Okay.
also influences its impact on weather patterns,
Wow.
how it interacts with sunlight, and even its ability to produce precipitation.
That brings us to our second factoid,
Yeah.
which is all about condensation,
Okay.
the process of water vapor transforming into liquid droplets.
Right.
It sounds pretty straightforward,
It does.
but I'm guessing there's more to it than meets the eye.
Oh, there is.
Tell me more.
You see, condensation doesn't just happen randomly.
Hmm.
It's all about a delicate balance between temperature and pressure.
Okay.
When warm, moist air rises,
Uh-huh.
it expands and cools.
Right.
As the temperature drops,
Okay.
the air's capacity to hold water vapor decreases.
Oh, I see.
And that's when condensation kicks in.
Okay.
It's like the air reaches a saturation point,
Yeah.
and those excess water molecules are forced to come together
Okay.
and form those tiny droplets we see as clouds.
It's fascinating
Yes.
how these seemingly invisible forces
Yeah.
are constantly at play in the atmosphere,
Right.
shaping the weather we experience.
Absolutely.
And it brings us to our next factoid,
Okay.
which delves into the rather surprising role
Okay.
of microscopic particles in ice nucleation,
Right.
or the process of water freezing into ice crystals.
Interesting.
These aerosols we talked about earlier
Yeah.
play a crucial role here as well.
That's right.
So not only do these aerosols act as gathering points for water vapor,
Uh-huh.
but they also influence whether that water turns into liquid or ice?
Exactly.
Wow, that's amazing.
Without those microscopic particles, cloud formation would be much less efficient.
Oh, really?
Think of it this way.
How's that?
Pure water actually needs to be cooled to a much lower temperature than we typically see in the atmosphere to freeze.
Interesting.
But the presence of these aerosols
Uh-huh.
provides a surface for the water molecules to latch onto and organize themselves,
Okay.
making it much easier for them to transition into ice crystals.
That's incredible.
It is.
It's like those tiny particles are acting as tiny ice sculptors,
Uh-huh, yeah.
shaping the structure of the clouds.
That's a great analogy.
Thanks.
And the type of ice crystals that form, whether they're delicate snowflakes or chunky hail,
Right.
depends on factors like temperature,
Okay.
the amount of supercooled water present,
Uh-huh.
and even the shape and composition of the aerosol particles themselves.
It's mind-boggling to think about all these microscopic interactions happening high above our heads,
I know, right?
influencing everything from the type of clouds we see to the weather we experience.
It really highlights the interconnectedness of everything in the atmosphere,
Yeah.
from the tiniest particles to the vast weather systems that shape our planet.
So we talked about how clouds form
Right.
and the different types of particles they contain.
Yes.
But what about how all that translates into the rain,
Okay.
snow,
Yeah.
or hail we see falling from the sky?
Good question.
That's where our fourth factoid comes in.
Okay.
Precipitation.
Right.
Precipitation is essentially the process of those cloud droplets or ice crystals
Uh-huh.
growing large and heavy enough To overcome the updrafts in the cloud
Right.
and fall to the ground.
So it's a battle between gravity
Yeah.
and the air currents within the cloud.
Okay, so it's a battle between gravity and the air currents within the cloud.
Exactly.
Gotcha.
And the winner of that battle
Right.
determines whether we get a light drizzle,
Mm.
a torrential downpour,
Wow.
a gentle snowfall,
Okay.
or a barrage of hail.
So how does a type of cloud influence the type of precipitation we get?
Well, it all comes back to the chemistry we've been talking about.
Oh, okay.
Clouds composed primarily of liquid water droplets
Uh-huh.
are more likely to produce rain.
Rain. Okay.
However, if the temperature is below freezing
Right.
and the cloud contains a mix of supercooled water and ice crystals,
Oh, okay.
you'll get a process called the Bergeron process.
The Bergeron process.
Where the ice crystals grow at the expense of the supercooled water droplets,
Interesting.
eventually becoming heavy enough to fall as snow air.
Okay. Forms in thunderstorms where strong updrafts repeatedly lift the ice particles back up into the supercooled region of the cloud. Wow. Allowing them to accrete more and more layers of ice.
Interesting.
Until they're too heavy to be supported and fall to the ground. So each type of precipitation has its own unique formation process,
It does.
all dictated by the chemistry of the cloud and the conditions within it.
Exactly.
That's amazing.
And it's incredible how something as simple as the temperature of a cloud
Right.
can influence whether we get a gentle rain shower
Yeah.
or a destructive hailstorm.
It really makes you appreciate the power of nature
It does.
and the complex processes that shape our weather.
Right.
And it brings us to our fifth and final factoid for this part of the deep dive,
Okay.
which is all about atmospheric optics.
Oh, right.
Those stunning visual displays like rainbows and halos that we sometimes see in the sky.
Oh, those are cool.
I've always been fascinated by rainbows.
Yeah.
And I've heard they have something to do with light being refracted through water droplets.
That's right.
But what about those halos you see around the sun or moon sometimes?
You're right about the rainbows.
Okay.
They form when sunlight is refracted
Uh-huh.
or bent
Right.
as it passes through raindrops.
Raindrops,
The
okay.
different wavelengths of light
Right.
are bent at slightly different angles,
Hmm.
creating that spectrum of colors we see.
Oh, cool.
Halos, on the other hand,
Okay, halos.
are caused by light interacting with ice crystals in cirrus clouds.
Ice crystals, okay.
The hexagonal shape of the ice crystals acts like tiny prisms,
Prisons, right.
refracting and reflecting light in specific patterns,
Uh-huh.
creating those circular halos around the sun or moon.
So it's not just the presence of water in the atmosphere that creates these optical phenomena,
Nope.
but also the shape and structure of the particles themselves,
Exactly.
whether they're liquid droplets or ice crystals.
Precisely.
That's fascinating.
And it's another beautiful example of how the chemistry of clouds can create some truly awe-inspiring displays in the sky.
Well, I feel like we've already covered a lot of ground here.
We have.
We've gone from those seemingly simple, fluffy white masses in the sky
Right.
to a world of microscopic particles,
Uh-huh.
complex chemical reactions,
Yeah.
and even stunning optical displays.
It's amazing how much there is to discover about something we see almost every day, isn't it?
It is.
And we've only just scratched the surface.
I know, right?
There's still so much more to explore about the chemistry of clouds.
Oh, wow.
And how it impacts everything from weather patterns to climate change.
That's what I love about these deep dives.
What's that?
We start with something familiar
Yeah.
and then dive into all the fascinating science behind it,
Right.
revealing a whole new level of complexity and wonder.
Absolutely.
So I can't wait to see what else we uncover in the next part of this deep dive.
Me too. It really is remarkable how much depth there is to something as seemingly simple as a cloud.
Absolutely. And speaking of depth, I'm curious about how deep these chemical processes go. We've talked about water vapor, aerosols, and ice crystals.
Right.
But are there other chemical reactions happening within clouds that influence their behavior?
That's a great question, and it's an area of active research. Clouds aren't just static masses of water and particles.
Right.
They're dynamic systems where various chemical reactions can occur,
Hmm.
influenced by factors like sunlight,
Okay.
atmospheric pollutants,
Oh.
and even biological activity.
Wait, biological activity? Are you telling me there's life inside clouds?
In a way, yes.
Wow.
Microorganisms, including bacteria and fungi,
Hmm.
have been found living within cloud droplets.
That's wild.
They can be carried up into the atmosphere from the Earth's surface
Right.
and can actually influence cloud chemistry in subtle ways.
So we have these tiny ecosystems floating out above our heads,
Yeah.
potentially impacting the weather.
It's a fascinating concept, and scientists are still trying to fully understand the extent of their influence.
Wow.
Some studies suggest that certain bacteria might even play a role in ice nucleation,
Really?
further enhancing the cloud's ability to produce precipitation.
It seems like every time we peel back a layer of the onion, we find even more complexity and interconnectedness within the Earth's systems.
That's the beauty of science. There's always more to learn and discover, even about things we think we understand.
Right.
Now, shifting gears a bit,
Okay.
I'd like to touch on a point we briefly mentioned earlier.
Uh-huh.
The impact of atmospheric pollutants on cloud chemistry.
Yes, that's something I've been wondering about. We know that air pollution is a serious problem.
It is.
But how does it actually affect clouds?
Well, pollutants,
Okay.
particularly those from industrial emissions and vehicle exhaust,
Yeah.
can alter the chemical composition of clouds in a couple of ways.
Hmm.
Firstly, they can increase the number of aerosols available for cloud condensation and ice nucleation.
Okay.
While this might sound like a good thing in terms of enhancing cloud formation,
Yeah.
it can actually lead to clouds with smaller droplets
Uh-huh.
that are less efficient at producing precipitation.
So more pollution could actually mean less rain.
In some cases, yes.
Wow.
And secondly, certain pollutants can react with the water molecules in clouds,
Okay.
forming acidic compounds.
Oh, no.
This can lead to acid rain,
Right.
which can have harmful effects on ecosystems, infrastructure, and human health.
It's a stark reminder that our actions on the ground can have far-reaching consequences
They can.
for the atmosphere and the delicate balance of the Earth's systems.
Absolutely. And it brings us to a point that's relevant to a current conversation.
Okay.
The impact of climate change on cloud formation and behavior.
Yes, that's something I've been wanting to ask about. We hear a lot about climate change affecting weather patterns.
We do.
But how does it specifically relate to clouds?
That's a complex question, and scientists are still working out all the details.
I can imagine.
However, it's clear that rising global temperatures are having an impact on various aspects of cloud formation,
Okay.
from the amount of water vapor in the atmosphere to
Right.
the distribution and types of clouds forming.
So could climate change lead to more extreme weather events,
Potential?
like droughts or floods,
Uh-huh.
due to changes in cloud patterns?
It's certainly a possibility. Some studies suggest that climate change could lead to an increase in the frequency and intensity of certain extreme weather events,
Really?
partly due to changes in cloud cover and precipitation patterns.
It's a sobering thought,
It is.
but it also highlights the importance of understanding these complex systems
Right.
so we can better predict and mitigate the impacts of climate change.
I completely agree. And it brings us back to the importance of scientific research
Yeah.
and the need to continue exploring these intricate processes that shape our planet's atmosphere and climate.
Well, I feel like we've covered an incredible amount of ground in this deep dive.
We have.
From the microscopic interactions within cloud droplets
Yeah.
to the global impacts of pollution and climate change.
Mm-hmm.
It's amazing how something as seemingly simple as a cloud could be so incredibly complex and influential.
It really is, and I think it's a testament to the beauty and wonder of the natural world,
That's right.
that there's always more to learn and discover,
Yeah,
even about things we encounter every day.
I couldn't agree more. So what else is there to uncover about the world of clouds?
Well, one fascinating area of research is the potential for cloud seeding,
Cloud seeding.
a weather modification technique that involves introducing particles into clouds to try to enhance precipitation.
That sounds almost like science fiction. Are you telling me we can control the weather?
Not quite control, but cloud seeding has been used in various parts of the world with some success,
Oh, wow.
particularly in regions experiencing drought.
How does it actually work?
The idea is to introduce particles,
Okay.
often silver iodide or dry ice,
Interesting.
into clouds that lack sufficient ice nuclei for efficient precipitation formation.
Okay.
These particles act as artificial ice nuclei, promoting the Bergeron process and potentially increasing rainfall or snowfall.
That's incredible. It sounds like a promising solution for water-scarce areas.
It does.
But are there any potential drawbacks or ethical considerations?
There are certainly ethical considerations surrounding weather modification,
Right.
as it raises questions about potential unintended consequences
Yeah,
and who gets to control such powerful technology.
I see.
There are also concerns about the effectiveness and cost-effectiveness of cloud seeding,
Okay.
as well as potential environmental impacts.
It sounds like a complex issue with both potential benefits and risks that need to be carefully weighed.
Absolutely, and it highlights the importance of having open and informed discussions about these emerging technologies and their potential impact on society and the environment.
Well, this deep dive has certainly given me a lot to think about. I'll never look at a cloud the same way again. It's incredible to think about those tiny droplets and particles we talked about actually having such a significant impact on our planet.
It is, and it speaks to the interconnectedness of everything in the Earth's systems. Even seemingly insignificant components can play a crucial role in the larger picture.
Absolutely. Now, before we wrap up this deep dive, I wanted to circle back to something we touched on earlier, those stunning optical phenomena like rainbows and halos.
Right.
We talked about how they're formed by light interacting with water droplets and ice crystals, but are there any other fascinating optical tricks that clouds can play?
There are. Have you ever heard of iridescent clouds or cloud iridescence?
I can't say that I have. What is that?
Imagine seeing clouds shimmering with vibrant, almost pastel-like colors. It's a relatively rare phenomenon,
Hmm.
but it occurs when sunlight is diffracted
Okay.
or spread out
Right.
as it passes through tiny water droplets or ice crystals of a uniform size in the cloud.
So it's similar to how rainbows are formed,
Yeah,
but instead of those distinct bands of color,
right.
we get this shimmering iridescent effect.
Exactly, and the colors can be quite striking.
Oh, wow.
Ranging from pinks and greens to blues and purples. It's almost like seeing a giant sight bubble in the sky.
That's amazing. I'll have to keep an eye out for that next time I'm cloud gazing.
You should.
Now, as we wrap up our deep dive into the world of cloud chemistry, is there anything else you think our listeners should know or any final thoughts you'd like to leave them with?
Well, I think the main takeaway from this deep dive is that clouds are far more than just those fluffy white masses we see in the sky.
Right.
They're complex dynamic systems that play a crucial role in the Earth's climate, weather patterns, and even the water cycle.
Absolutely.
And by understanding the chemistry behind cloud formation and behavior, we can gain a deeper appreciation for the intricate processes that shape our planet and the delicate balance of the natural world.
I completely agree. It's been an eye-opening journey, and I feel like I have a whole new perspective on those seemingly simple clouds I see every day. So next time you're looking up at the sky, take a moment to appreciate the complex chemistry happening above your head. Who knows what other secrets and wonders those clouds hold?
Exactly. There's always more to discover.
Well, on that note, I want to thank you for joining us on another fascinating deep dive. We'll see you next time, ready to explore a whole new realm of knowledge.